Okay, good afternoon. Let us start. So, how many screens do you prefer? One or two?
Two.
Okay, but I can only use the marker to.
That's fine.
That's fine?
We cannot see clearly.
Okay. So, does the size of font look okay to everybody? Mm-hmm. If not, I can enlarge it a little bit. Bigger, please. Okay. Problem is that when I enlarge it, kind of. Is it fine for everybody? Mm-hmm. This looks like when you enlarge it, it just enlarges to some extent. It's not like a smoothly.
Can you change the resolution in your display settings?
Yeah, forward.
The resolution, right?
Resolution and display settings, I think might do it.
Well, this is a VGA interface. So by default, the resolution won't be very high. But I can try.
displays.
Does it look better? Oh, beautiful. See whether we have a high resolution slice. Yeah. Does it look better? Yeah. Small. Yeah, it looks much smaller. Oops. Oops. Maybe let me try to see whether large from browser. Is this better?
Yes.
Yeah.
Everyone is fine with this? Okay, great. So let us continue the reading policy. So we have mentioned that homeworks, we plan to have 6 homeworks with pretty heavy programming assignments. That means you need to implement almost all the machine learning models and algorithms we introduce in class and test them, prove, demonstrate that they work on real data sets. And you need to ensure your code is executable on located machines because our TAs or TMs and TMs will try to run the code to ensure that the result, the report in your homeworks assignments is not fake. And you can, unless we explicitly mention in the homework assignments, you are free to use arbitrary, like linear algebra, matrix computational libraries. Typically, if you use Python, that will correspond to NumPy and SciPy library. If you use MATLAB, then just use it by default. R also has this matrix operations as well, but you're never allowed to call some APIs, which is direct implementation of some learning algorithm. Like, I ask you to implement an SVM classifier. While in scikit-learn this package, there is one line of code. You call it, you finish the homework. That's not allowed. So actually, by the end of the semester, we hope you have built up your own scikit-learn library in GitHub. And let's just skip the course project right now. So, and then a final exam. We don't have any midterm exam. Only one final exam, and it's open book. You can bring whatever books, documents, or you can even print out all the slides if you like. And for the exam, you don't need to memorize all the formulas and models. But do not bring the electrical devices, especially those ones can get access to the internet. Otherwise, I don't know whether you're text messaging to other people outside. It's just for fairness. And then we'll talk about in detail the course project. So this is very important. Everyone needs to use machine learning to do a project to solve whatever problem you think is interesting or important. you think it's necessary to use machine learning technique. And you can take a look at the course webpage. We have one particular section talking about the course project. Does it look good for everyone? Okay, so the project is worth 30% of your final grade, so it is important. And you should start to do, or start to consider what kind of project you want to do right now, because we expect that throughout this semester you are, along with your project, you're trying to finish it. So the project can be broken into 3 milestones. So first milestone is the simplest one. You need to form a team. Of course, you can do the solo project. That's fine. That's totally fine. But if you want to form a team, try to find a partner. And the project has at least 2 people. And then, in the middle of the semester, typically it will be right before the spring break. You need to submit a midterm project report. So the midterm report should clearly introduce the problems you want to solve and explain the motivation, like why you want to do this problem. You can say, okay, I'm interested in doing that. That's fine. And or you think it's necessary, and why do you think using like non-machine learning method is not feasible? Why machine learning must kick in? And your preparation for this project. What you have done for this project? If you just say, I have collected some data, that won't be sufficient. So the ideal status will be, okay, I collect the data, pre-process the data, I find some properties about this data, and then I design some baselines. Whenever you want to use some method to solve a problem, you need to show the advantage of your methods, right? How do you show the advantages? Comparing with some simple, naive, or traditional methods. At least you have to prepare those competing baselines. And also, you can release some preliminary results. For example, if I use some simple heuristics which are quite popular before machine learning shows up, then I can show, if I use heuristics, simply heuristics, what is performance, and what is my expectation when I use machine learning. And then what's your detailed plan for the rest of the project? So in the remaining half of the semester, what are you gonna do to finish the project? What kind of algorithm do you want to choose? And do you have any backup plans? What if it doesn't work? And finally, remember to put reference to the literature, because this is a serious attitude. Because if you want to do any serious work, scientific work, you need to cite the existing work. So don't forget to place the reference to the literature. So at the end of semester, you need to submit the final report. So here's the final report does not necessarily to be is not necessary to be very long because we don't have energy to read the novel. Right? So at least 6 pages, and 6 pages are really long enough for you to put all the results. Believe me. And the structure of the final report should be like this. First, problem definition. Give the rigorous definition of the problem and explain the motivation. And then present your solution. If your solution involves some machine learning models, write down the objective of the function show your derivation of the gradients and what kind of optimization algorithm do you use to train the learning algorithm. So, and then the details about experimental evaluation. Okay. So what kind of data sets, the description of the data sets, how do you pre-process the data sets, and how do you do the cross-validation to choose the appropriate hyperparameters, why it is reasonable, and how do you run other algorithms, how do you choose the parameters to run other algorithms as well. More detail, more better. And draw the figures or report the comparing results in terms of tables. Give us numbers and show us the trends. And then given those figures and tables, tell us your conclusion, tell us your observation. The key point is that all your conclusion should be based upon your experimental results. Your conclusion cannot be baseless. You must be objective. And then 5 points is allocated to the future plan. Sorry. To the future plan. So although you are not necessary, you are not obligatory to do some future extension of your work, but at least you should have a custom to think. You should have a habit to think of after this project is done, what can I do to further improve my algorithm if I have time in the future. So, I mean, truly in the future, whatever job you do, right, you finish one project, when you hand in the project to others. So people always need to think about what's the next step. How can I smoothly transit this work to others and let others to further improve your work or expand your work. And some of you may choose some purely theoretical project. For example, I want to prove a tighter generalization error bound for some particular type of algorithms, or I can show some algorithm, some sample complexity, like to gain the particular accuracy. You can do that if you prefer to do this, but please come to my office and talk to me. And if your project is purely theoretical, that means there is no numerical. There could be some numerical experiments, but if there is really no way to check or evaluate your method or your theory by some real experiments, that's fine. And then we'll grade the solution part and experiment part together. And one important point is that the final report must contain a link to the GitHub. As I mentioned in the last lecture, you need to create a GitHub repository. It contains all the code and documentation of your project. Because we will not only read the midterm report, final report, we also check whether you really do the project. You cannot imagine all the results and draw the figures. So actually, this is an issue, even in machine learning research. Several of you have heard about the reproducibility crisis, right, in the machine learning data science research. We're trying to ensure every work is reproducible, not only looking at papers. So here, so if you want to know the detailed requirements, just to check the website. Okay. So the next question would be, what kind of project topics? So we don't have any restriction on the possible topics for the project. You can choose whatever you want. And as long as you show that, or you claim that, machine learning is one important step, and is a step which cannot be replaced. That's okay. You can, if you're a PhD student, you can even put your research project as our course project, as long as your advisor allows you to expose the code implementation in a GitHub repository. So here we list a set of topics, or the way you can choose topics from. Say an application project. So you can consider whatever applications you think which can be improved or can be finished by machine learning. Or you can simply read some paper published in NIPS or SML, those top machine learning conferences which you think interesting, and you can try to reproduce the published results. A theoretical project, as we just mentioned. Algorithmic project, for example, some machine learning algorithm is quite computationally expensive, and you invent a much more efficient algorithm which can reduce the time complexity or space complexity by a factor of 10 or by a magnitude of orders of magnitude. That's really cool. Or even your own research. If you are already working on some research project and you want to involve some machine learning techniques, you can also improve this in your course project. And also, experimental evaluation should be rigorous. And you need to write down the experimental part as detailed as possible. So here are a few project examples. So an interesting set of machine learning tasks is from Kaggle. So how many of you have heard of Kaggle? Wow, that's good. That's good. So Kaggle is a very big data science website, and all the data is available from small scale to large scale. And from time to time, Kaggle will hold some competition for some particular tasks. That's what this link tells about. So this Kaggle competition task. So if you're interested in, or you're really not sure what you should do, you can click into this link. And you can see. There are many Kaggle competitions on different tasks. For example, predict the stock movements using news articles, and analyze NFL computation and doing prediction and recommendation and etc. So very interesting, and the data are there. So even you do not attend the competition in the website, the Kaggle website, there are a lot of data sets. You can even just download some data set and do something on that. That's okay. You do not need to really attend this competition. But of course, if you attend this competition and you are ranked like top, you will win. You also earn some money. So that's good for you. So another example is some example I done before. Right? So the biological medical study, gene selection. Can we select a subset of genes, like out of thousands of hundreds of thousands genes? Can we select a subset of genes relevant to some cancer, like brain cancer, or relevant to some dementia? Stock market prediction. Can you download some stock market data and predict the trend of stock price? Commodity recommendation. Right? There's very famous data set called Netflix data set. So Netflix will periodically open some data set and call for competition. And if you can build up some algorithm to improve their recommendation accuracy, you will not only earn some money, it is highly likely that you will be recruited from them, and with very high salary, much higher than mine. So try to, yeah, you can try to do that. And software security. Can you build out a machine learning model to predict whether this software in an app store is a malware or could have some malicious behaviors or not? Right? This is also quite hot topic in computational security. Many security researchers trying to build out machine learning models to predict security leaks, or even identify the blocks of the code which might have bugs. So this is a very interesting research topic. Sentimental analysis, giving you a paragraph of text or giving you an article, right? Can you predict whether there is a strong emotion? Like this article expresses, likes somebody very much or hates somebody very much. It's called sentimental analysis. And this actually is very important. It's very important. And people like Amazon or eBay, they often try to do the sentimental analysis on the text comments, the product reviews in their website. If the customer expresses strong feelings about product, those customers are really valuable, and they want to know why they hate it so much or like it so much. Spam emails detection. So spam email filtering is a basic function in modern email system. So how about you implement a spam email filtering system by yourself by using the machine learning models we introduced in the class. So here are just a few examples. And if you decide to take this class, I'll suggest you to think about what kind of project you'd like to do in this semester. Start to think about right now. Don't hurry up at the middle of the semester. That would be quite painful. Okay, any questions regarding the project?
Would code for the project, would it have to be the stuff that we've written previously in class, like using the stuff that we've coded, or could we use libraries?
Very good questions. There's something I forgot to mention. This is not necessary. You can use the implementation from your own machine learning library. That means your own implementation, or you can call whatever machine learning package. That's fine. Because I know someone, if for some difficult task, if you really want to achieve high performance, your own implementation might not be sufficient enough. In this project, our aim is trying to train your skills to select appropriate machine learning models and algorithms and build up your own solutions. So you are not required to implement everything from scratch.
Just to reiterate what you said, on projects, we can use any library
Yes.
available publicly.
Yes.
Thanks.
You can use scikit-learn, you can use TensorFlow, you can use PyTorch, whatever you want. Or you can build up the wheels by yourself. That's fine. That's the point. Okay, great. And if you're still unsure about the topic, or if you choose some topic but you're not sure about that, you can come to the office hour and talk to me, or you can come to the TA's office hour. But just one suggestion, start to think about it right now. Don't delay. Okay, so let us get back to the syllabus. So the letter grade mapping. So we don't curve your grade. And but for undergrad course and grad course, we have different standard to map your numerical grade to the final letter grades. So basically, it is a little harder for grad students to obtain A or A minus, but the gap is not large. The gap is not large. And I can tell you, don't worry, as long as you listen to the lecture carefully and take the course seriously, finish the homework on time, it won't be, I don't see any difficulty in obtaining an A minus. But if you want to get an A, you really need to make some efforts to spend some time, devote your time on that. And I hope at the end of this semester, everybody will get at least B minus. I really don't want to see like B plus or B in this class. Does that make sense to you? And one detail. So when we got the weighted combination of the numerical grades, we got the final numerical grade, right? When you try to map your numerical grade to letter grade, we do some round-up. So for example, if your score is like 90.6, it will be rounded up to like 91. That means you got an A if you're a graduate student, right? But if unfortunately you get 90.4, it is truncated to 90. So someone might feel urgent to get like even better grade, right? For example, he got 90.4, but he still wants an A. So what's the solution? You can come to my office, and we'll look at all your homework assignments, your course project reports, and the final exams, and try to find some extra points to enhance your grade. But if we still cannot find any extra points, you just maintain the grade. You are where you are. Does that make sense to you? Okay. And one final exam. This is important dates. The final exam is on Monday, April 29th, between 6 and 8 p.m. in the same classroom. And it sounds long after, right? But it is approaching fast. And when we approach the end of the semester, we will keep reminding you in the canvas to ensure everybody ends up showing up in the final exam. So, late policy. So, each assignment should be submitted through Canvas according to the designated deadline. It's usually on 11:59, that is before the midnight. And if you miss the deadline, your late submission will automatically be penalized by 10% credits. And every subsequent late submission will receive, will lose another 10% of credits. So for example, if the total points is 10, if you miss the deadline, and you submit until 30 hours later, then you will be penalized for twice. Okay. First, everyone just 1 point lose. You finally end up with 8 points. But you can not submit the homework 2 days later. I mean, later than 48 hours. That means you will receive a 0 grade. So I don't want to see any of you lose the grades due to the late submissions. So try to do the homework earlier and submit the homework by time. So if you have some like a long-term illness and you really need to extend the deadline, and send an email to me and give me the doctor's notes. homework submission. So we only accept homeworks written with LaTeX. So LaTeX is kind of must know skills. Whenever you write some scientific report. So if you never used LaTeX before, this is a good time to learn to use it. And it's very simple. As long as you set up your LaTeX environment, set up your there are many softwares in both Mac and Linux and Windows platforms. And also we'll provide the templates. Whenever we release the homework, we also release the LaTeX source of the homework. So you can directly add it on the LaTeX source and just compile it. It's pretty convenient. Attending final exam. Final exam is important. Don't try to don't miss it. So if you have some plan which you have to escape from the final exam, let me know beforehand. We might be able to schedule an exam before the final exam. And if you miss the final exam due to some emergency, for example, you have to call 911 to deal with some things like fires, or you have to go to the emergency room, let me know within 3 days of the exam. Then we can schedule a makeup. Academic policy. These are all the, everything you should be familiar. Don't cheat, don't plagiarism, don't plagiarize, and if you are encouraged to discuss how to solve homework problems offline, don't discuss it online. Don't post your solutions online. But you can discuss freely offline. But you need to write your solutions and implement your code by yourself. If you're worried that even you do it by yourself, you and your friends will end up with very similar solutions, very similar code. Write a note in front of your homework solution and explain to what extent you're collaborating with. Otherwise, if we find out if your two solutions are nearly exactly the same, almost exactly the same, then we'll consider it as cheating or plagiarism. Then the grade for both homeworks will be 0. And students with disabilities, if you have some kind of issue, do not hesitate to send an email, and we'll contact departments in our university to offer the help. Okay, so any questions or concerns?
When it comes to using K, is that going to be a different process? Is there a walkthrough we can follow? Not familiar with K at all.
What do you mean by K?
K? C-A-D-E?
Oh, K machine.
K machine, yeah.
So basically, K machine is just the commonly used commonly platforms, and you need to ensure your algorithm is runnable, is executable on the K machines. That means you need to ensure your algorithm can be deployed on the commonly used platforms. Right? So I would suggest you to spend some time. If you don't want to debug your code or test them on K machines, that's fine. You just take some time, go to the K machine for 1 afternoon and write down some code, ensure it works well on K machine, and then copy that code because you have all the environmental information, and then develop everything in a framework. Does it make sense to you?
Yeah, I think it makes more sense.
Are you a CS student?
No.
I can show you how to class.
Okay.
Yeah, actually there are a lot of computer labs here. It's abundant computer labs, and there is even some remote connection to the K machines. So even you use your own laptop, you can upload your code to the K machines remotely and run it for test once for all. Any other concerns or?
So a little clarification on chemistry and graduate. On the graduate, it's just the curve that's different. There's not going to be any actual assignments for graduate students or actual problems on the tests or anything like that.
The problems and tests are 99% exactly the same. If there's an actual problem for grad students, I will indicate in the assignment. So, but in most of the cases, you have to deal with exactly the same set of problems. But we don't curve your grade. We just map them through different standard.
On the first homework, did you indicate the difference between the undergrad problems and the graduate problems?
No. Because these problems are quite fundamental. I believe every one of you is able to do that if you take some probability statistics class and take linear algebra class. Is able. The first homework has nothing to do with programming assignments, but that's fine. And you should be able to do that. If you feel unfamiliar, just open the book, your textbook. But still, but if you still feel very hard, then be careful. And I would suggest you to consider for a while and maybe take the class next time, because we won't spend time teaching you like how to do the matrix product, right? How to calculate log determinant of the matrix. We won't do that. We'll assume you have already know that. But if there's a severe problem in basic knowledge, I won't suggest you to take this class this time. Anyway, we have every semester we have this class open. You won't lose anything. I don't want this class to depress you. Is it reasonable? Okay. Any other questions?
Are the homework, is it like 2 to 3 weeks for each assignment approximately? Is that
Yeah, approximately 2 weeks.
okay?
If it is possible, I will try to make the interval between successive homeworks as long as possible. But we plan to have 6 homeworks, so you can count. So it should be like about 2 weeks per new homework will be released every 2 weeks, 2 or 3 weeks. But don't worry, I won't give you homework during the spring break. I won't destroy your spring break. Any other questions? All right. So if you still feel unclear about the course policy and every schedule of policy, you can check the syllabus online and also look at the course website. And also, as long as there are any updates, we'll make announcement in the Canvas, also update the course website and syllabus. And if you still feel unclear, send me an email or I'll post a question on Canvas. I will try to respond to you as fast as we can. Okay, so let us go back to slides. So I have finished the overview of this course. So how you will learn from this class? What's the correct way? What's the most effective way to learn this class? Take classes. So if it is feasible, if feasible, just come to the class and follow the instructors, review the lectures. This is the most effective way to learn. And if you escape the class and then watch the video, that's fine. That's fine. I mean, several of you might have to leave the class early or to miss some class. That's why we have the camera. We record the class and to keep to maintain a high resolution as high as possible. But the most effective way is always to listen to the lectures and follow, and also trying to interact with the instructors to ensure your learning procedure is highly efficient. Then you won't spend too much time online, offline, and then you can extend your ability or deepen your understanding by doing homework assignments. That's the most effective way. And finish homework assignments by time and seriously. So sometimes you may feel, okay, it's kind of heavy doing those kind of stuffs, but only through practice you can learn and you really learn something. Right? When I talk to you, okay, this algorithm, the first step is what, and what's the first step, what's the next step, what's 3 steps, and we can do some loop and Q convergence. Sounds really simple, right, and naive. But when you implement by yourself and try to debug and make it work, that's different. That's really different, I can tell you. And then your view about this algorithm, and then about whether this work and in what kind of situations they work is totally different. Yeah, implement learning algorithm models by yourself, and then doing the cross project, try to solve the problem. So this is a very simple suggestion. As long as you follow it, you will get high grade, and also you will really learn something. And I want to emphasize that because in the previous semesters, some students questioned that we should entirely focus our energy entirely on deep learning. Well, unfortunately, this class is not deep learning class. So we'll definitely cover deep neural nets and tell you what's the basic idea about deep neural nets you're required to implement backpropagations by yourself. But we do not specialize on deep learning. There is a perfect class, there's a great class in our department, it's called deep learning. If you're really interested in that, you can take that class as well. And our course is more broad. We want to cover many successful and classical machine learning algorithms such that you can build up a more general framework about machine learning. Any questions?
What's the other class name?
What?
Deep learning.
It's just called deep learning.
Computer learning.
It's not computation learning. It's just called deep learning.
Okay.
Yeah. You can search from the course catalog.
Okay.
There's one class. I don't know whether it is still open in this semester, but last semester it is open.
It's also from the CSI.
Yeah.
You say it was offered every single semester? So it's
No.
What?
It was a special topics class last semester.
Yeah. She's right.
So not necessarily next fall.
Oh, it should be. Because the course, it is our department head who wants to open this course. So I think the continuation should be guaranteed. Right? Any other questions? Okay, great. Again, I mentioned again, trying to track the updates in the course webpage, and also watch the status, watch the announcements and discussions on campus. We really want to build up an active learning environment, so don't hesitate. Come to the office hour, talk to us if you have any problems with this class, and also in the offline, try to post your questions, try to discuss through cameras, where we're always online. So okay, they will spend like 10 or 15 minutes to do a review of basic knowledge. We just want to remind you those basic concepts and also enforce you to open a textbook and yeah. So first, the definition of random events and random variables. So to represent some random events using mathematical languages, we use sets, right? So for example, if I do some experiments, like I toss a coin, I want to represent the tossing results, whether you have a heads up or tails up, right? And then we can represent the results in terms of sets. So for example, if I toss a coin for 5 times, how can we represent the results? We can use a set, right? To represent even A, which has 3 times we have a head up, and 2 times we have tails up. And another event, which is represented by another set, which indicates we have 3 tails up and 2 heads up. So set is the basic element to represent random events. And then to measure the chance that a particular event happens, we assign some probability measure on those sets. So what is probability? So it is essentially a mapping from sets to a number, which is between 0 and 1. So we can say, okay, PA is, when we say PA is 0.5, means that we have a half chance to have this event A. That means 3 heads up and 2 tails up happen. And also we can assign a probability measure on the another event B. And then the convenience of using sets is that we can use set operations to create more complex events. So the basic methods to the union or intersection between sets. So we can create a new, given an event A and event B, right? We can create a new event that both A and B happen. Then how can we represent this new event? An idea?
Another set?
Yeah, another set. Yeah, exactly, another set. We just create another set which is an intersection between A and B. That indicates the event that both A and B happen. Right? And another type of new event can be created as either A happens or B happens. So remember, either A and not either A or B, it's actually A or B happens, right? A and B can both happen, or just one of them happen. This is different from the event that both A and B happen. So how can we represent this event?
Another set?
Of course, another set. How can we construct another set?
So it's been a minute since I've taken probability and statistics. So
That's fine.
those 2 sets right there,
Yeah.
the order doesn't matter. So
Doesn't
the
matter.
intersection between those 2 would look like, because if you have a head on the first one, tails on the first one, and B, they're mutually exclusive. Like only one can happen. So what would the intersection look like?
You mean here?
Yeah.
Oh, well, here we actually don't care which head appears at which step, at which time. We just show this just to show, okay, we have 3 heads up and 2 tails up, no matter in which particular tossing. If you want to express that event, that would be a different set.
Even so, the count is different. So in this case, would we toss a coin 5 times twice? So toss it 10 times, or just toss it 5 times?
Oh, well, that's another problem. Well, you can consider as toss the coins for 10 times, but into 2 groups. So one group we toss 5 times. In another group, we toss another 5 times. But in total, you indeed toss for 10 times. But after the first group, you have one event, right? A. And after the second group, you have another event B. Is there anyone still feel confused about this? So now we going back to our question, right? So now I want to create a new event. The event says A or B happens. Then how can we create this event? We just union A and B, right? So this is just two basic rules. Well, come on, is it very hard, or is it too? I mean, just forget how to define events, right? Okay, so that's why we do the basic knowledge review, right? So basically, if you want to given two events A and B, that is represented by two sets. Right? If I want to create a new event that both A and B happens, this event is represented by A intersect with B. And if I want to create another event that A or B happens, then we use union section, with union operation. And then, what's the relationship between these new events and the previous events in terms of their probabilities? So here is the formula. The probability of A or B happens equals to the probability of A happens plus the probability of B happens minus the probability both A and B happens. That's the, I guess that's the first equation you encounter when you take the probability class, right? So of course, this is a extended version, far more complex. We'll consider like n events, right? So what's the probability of like if I have events like A1, A2 to AN, what's the probability of A1 happens or A2 happens or A3 happens or to AN happens? Then this formula will be much longer. But here, you need to know the simplest case, two events. Any questions regarding this? It's just the basic concepts. Okay, and then random variables. So using sets to represent random events is not always very convenient. So a more commonly used method is to assign the random outcomes to some numbers in the real value domain. So call this variables as random variables. So rigorously speaking, random variables are actually mapping from the sample space to some numerical range, like our real range or other range. But here we just consider it is some continuous variables or discrete variables, but it has some randomness along with it. And then we can use the range to represent. We can use we can represent some random events by saying, okay, a particular random variable falls in some range. For example, the temperature, tomorrow's temperature. And I can say, okay, a random event is tomorrow is warm. Then represented as a mathematical language, we can represent it as a condition that the temperature x, which is a random variable, is within some range, like between 75 to 85. So going back to our core-tossing example, for each core-tossing result, we can introduce a random variable x. So x equals to 1, meaning that we have a heads up, right? X equals to 0, meaning that we have a tails up. Right? And then when we toss a coin for 5 times, we actually define 5 random variables, x1, x2 to x5. Then how can we represent even that we have less than 3 heads? An idea? Come on, try to think about it.
You have to get a sample space, right? Like, it could be heads or tails, so you get the sample space at the bottom is going to be 2 to the 5th, and then you have to come up with the number instances where there are 3 heads up, and that's going to be your numerator, so whatever that is.
Yeah, absolutely. But here we want to use these random variables to express some particular event. So now we have 5 random variables which indicates the outcomes of 5 tossing results. Each variable is 1, meaning that okay, I have a head up. Otherwise, it is 0, meaning we have tails up. So given the 5 random variables, can be using some mathematical operations to express an event that after 5 tossing, we have less than 3 heads.
Three choose 5.
3 to what? Okay, you can just, the answer is here. The answer is here. Right? You just sum them together, right? And check whether it is less than 3. Obviously, right? Yeah. Because if it is tails, okay, it's 0, right? So if you add them together, if it is less than 3, meaning that you have less than 3 heads.
Okay.
This is just to show why it is convenient to introduce the random variables. So actually, when we deal with practical problems, we always try to express the random events in terms of mathematical operations over the random variables. This is just some. I guess when you take the probability course, you are required to compute the probability of such kind of inequalities, right? This is a basic practice. Here, just tell you why you are required to do these things. Because in practice, you need to first summarize. You need to first convert your interested event into such kind of inequalities, and then you use your technique you learned from the probability class to compute the probability. And then the definition of drawn probability and the conditional probability. Right? So the drawn probability of A and B is actually the probability of A and B both happens. That's the definition in terms of sets. It is equal to the probability of A times the probability of B given A. And also symmetrically, we have a probability B times the probability of A given B. And when we use random variables, we call this drawn probability also as drawn density, probability density. And the drawn density equals to the P of X, which is the marginal density, multiplying with the conditional density, P of Y given X. And symmetrically, we have a P of Y multiplying P of X given Y. This is the definition of drawn probability. And independence. How can we conclude 2 random variables are independent, or 2 random events are independent? Just check their drawn probability. If their drawn probability is equal to the production of their marginal probabilities, that is the probability of A and B both happen, is equal to the probability of A happen multiplying with the probability B happens, then A and B are independent. Right? Same for the random variables. The 2 random variables are independent if and only if their drawn density equals to the production of their marginal densities. And from this, we can also view independence as, from another angle. That is, that means if 2 variables are independent, then the conditional probability is the marginal probability. Right? So if you contrast the right-hand side here and the right-hand side here, you'll see actually B and A is are independent, means that the probability of B is exactly the same as the probability of B given A. This is also very intuitive, right? So no matter how your solutions are given, I'm still myself. What happened to me has exactly the same chance. And similarly, the same definition applies to the random variables. If 2 random variables x, y are independent, means that the marginal density is equal to the conditional density. And we can smoothly extend the conditional, the independency into the conditional dependency by given an actual random variable. So if we say, okay, the two events A and B given C are independent, it means that the conditional drawing probability P, A, and B given C equals to the conditional margin probability. Their production of conditional margin probabilities. And it's P, A given C multiplying with PP given C. And same applies to the same definition applies to the conditional density. So this is just the basic rules. And the definition for expectation variance. So expectation of the random variable x is simply the integration of x and px over the domain of x. And any function of the random variable itself is a random variable. So if you take a function of x, gx is another random variable. Now how can you compute the expectation of gx? You just replace the integration here with gx. You calculate the expectation of gx. And definition of variance. The variance is defined as the expectation of x squared minus the square of expectation. And variance is always non-negative. And this is just for the scalar version. And usually we're dealing with vectors. I mean, a set of numbers. We usually represent as vectors. Then we'll talk about the variance regarding vectors. We're not talking about scalars. We're talking about matrix. This matrix is called a covariance matrix. So if your vector is like n-dimensional, right? The covariance matrix will be n by n. And how to compute the covariance matrix? Just the expectation of xx transpose minus the expectation of x multiply the expectation of x transpose. That's the definition. And also, when we talk about matrix, when we say, okay, a matrix is no less than 0, it means that it is a semi-definite positive. Is anybody feel unclear about the semi-definite positive, semi-definite positive? What is a semi-definite positive? What's the properties if a matrix is semi-definite positive? Yeah. All the eigenvalues should be no less than 0. Any other properties? Well, okay. The quadratic form for any vector x, if your matrix, for example, the matrix A is a semi-definite positive, that means x transpose AX is always non-negative. Do I need to write it on the board? This is scalar, right? If you have an n by n matrix A, right? And if you have n by 1 vector x, x transpose AX is a scalar. If A is semi-positive definite, then whatever a vector you choose, you have this quadratic form always non-negative. That's the original definition of semi-positive definiteness. Of course, the direct conclusion is that if the matrix is semi-positive definite, then all its eigenvalue is a non-negative. So if you still, if you forget the definition of positive definiteness, just open the linear algebra book, take it as a reference. And you need to keep in mind that covariance matrix is always non-negative. So in the future, if you are asked to implement a probabilistic learning model and that requires some covariance matrix, and when you debug it, found your covariance matrix is not positive semi-definite, that means there must be some bug. So we remember some, keeping in mind some mathematical knowledge will be useful. And conditional expectation and variance. So I can calculate the expectation of random variable x given another random variable y. Now how can we compute the conditional expectation? How can we compute it? Conditional expectation?
Can we replace the probability p of x
Yeah.
x given y?
Yeah. Very good. Right? It's just according to the definition, right? The conditional expectation of x given y here is just to replace p of x by its conditional probability. That's px given y. And similarly, if I want to compute the variance of the conditional variance of conditional covariance, how can I do that? The conditional variance will be the conditional expectation of x squared minus the square of the conditional expectation. So everything is the same except that we replace the marginal probability by conditional probabilities. But here, you should be aware there is a difference here. So is conditional expectation a constant or random variable? We know, okay, if I have a random variable, when I compute the expectation, it's a constant, right? Because there's no randomness with the expectation. But now, if I condition on some random variable, then I compute the expectation. Does this conditional expectation have randomness? Should it be treated as a random variable?
It's depends on y.
What?
It depends on y.
Why is a random variable?
So that should be right.
Any other comments or answers? Don't be confused at this point. You're right. It must be a random variable. You can consider, okay, when I do the conditional expectation, x, the random variable x disappears in the integral operation, right? So this is essentially a function of y. A function of y, but y is a random variable. Then a function of the random variable is still a random variable. So don't confuse. When you condition on some random variable, and you take expectation or whatever other operations, as long as that variable is not integrated out, it is always a random variable. So conditional expectation is still a random variable. That means you can still take expectation over the conditional expectation. When you take expectation over y again, then it becomes constant. If you have already started to do the homework, you should encounter a problem talking about this. And similarly, the conditional variance is a random variable. Any questions?
Are there discrete forms of these equations?
X and Y are discrete or not all continuous?
Like the top one, the expected value?
X could be discrete. When X is discrete, integration becomes summation. And so we can uniformly treat it as some integral operator. So remember, integration essentially is a summation. And you just a kind of summation when you take the limit. Right? So you can roughly treat them as the same operation.
Will that change the variance equation when you go e of x squared though?
No.
Also the same?
Yeah, because EX squared is simply the integration of x squared multiplied with marginal probability of x, right? So if it is discrete, just replace the integration with summation. The same thing. And this property that variance is always non-negative and the covariance matrix is always semi-positive definite. This is true whenever. It doesn't matter if your random variable is discrete or not. Any other questions? Okay, I really wish you can work seriously to solve the first homework to refresh your mind about all those concepts. You should all encounter this knowledge of these points before. Right? And then definition of convex function. And convex function is very important family of functions. Although it's very simple, but very important. And we'll mention convex functions many times throughout this semester. So what is convex function? First, convex function's domain is defined. It's convex domain. So what is convex domain? Visually, if you can imagine the domain, the input domain of the function, it cannot contain any inward part. It must look outward, like this. Why? Because convex domain requires that if I pick up arbitrary 2 points in the domain and then connect the 2 points, then you have a line segment, right? The segment is required to be completely included in the domain. So imagine if your domain, like at some part is kind of inward, like this. Okay. Then you pick up 2 points. It is possible that part of segment is outside domain. It crosses the boundary. Right? So you can see the right part is outside domain. So this is not convex domain. Convex domain must have all the points on the line segment to be included. This is the definition of convex domain. And a convex function is a function whose inputs are convex domain, but additionally, they must satisfy an inequality called convex inequality. So what does convex inequality say? It says that for arbitrary 2 inputs in the domain, x1 and x2, and we pick up weight t, which is between 0 and 1, then we can compute the combination of 2 points, which is t multiplied with x1 plus 1 minus t multiplied with x2. So this combination is called convex combination. The reason is that this t is between 0 and 1. If this is not between 0 and 1, it's not convex combination. And the convex inequality says that the function value at the convex combination of x1 and x2 must be less than or equal to the convex combination of the function values at x1 and x2. And that's t f x1 plus 1 minus t f x2. If the function f satisfies the convex inequality at arbitrary 2 points in the domain, then we call this function a convex function. So this is the definition of convex function. And to give a geometric example, a graphic example, right? So this function fx is a convex function. How can we justify it? We can pick up any 2 points, x1, x2 here, right? And pick up a t, which is between 0 and 1. Then the convex combination of x1 and x2 is in between. It's here. Then the function at the convex combination of inputs is here. So this is function value. Then the convex combination of fx1 and fx2 is here. So you can say the convex combination of function values is bigger than the function of convex combination of inputs. And this holds for arbitrary 2 points. So we can conclude that this function is convex function. So this is just a definition. Just definition. If you feel uncomfortable, just try to draw this line by yourself and check it by hand. Here are a few commonly used examples for convex functions. So for single variable, exponential function is a typical convex function. Negative logarithm of x is a convex function. You can use the definition of a convex function to prove that. And also, the example from a multivariable function case. So ax plus b, a is a matrix, x is vector, plus another vector. B is scalar. This is often called an affine function, although you can also call it linear function. But when you deal with a multivariable case, we usually call linear function as an affine function. Affine function is always convex. What?
B should be a vector.
No, B is a scalar. I'm sorry, I use bullied case. It should not be bullied.
If A is the tensor, X is the vector multiplication.
Oh, yeah. No. A is a vector as well. A is a vector as well. Okay, correct. And another case is the quadratic function. So negative half of x transpose x. Oh, sorry, this is not convex. This is you must remove the negative sign here. So the basic quadratic function, you should remove negative sign here. If you put a negative sign here, it becomes a concave function. So concave function is that the convex, you just change the direction of the inequality. It becomes bigger than or equal to, rather than less than equal to. Then it's a concave function. So in your homework, you are required to prove some multivariable function to be a convex function. How to do that? In addition to using definition, you can use the two commonly used properties. The first property is that if the function is differentiable, then for arbitrary two inputs, x and y, this inequality always holds. So fx is always equal to or bigger than at y plus the inner product between the gradient at y and x minus 1. So this is actually a first order Taylor expansion. You can consider it as a tangent line at the point y. That means if it's convex function, then the convex function must always stay above the tangent line. Try to visualize by yourself. That's the well-known property of convex function. And the second property, which is often used, is chapter hashing matrix. So if the convex function is twice differentiable, then it is convex if and only if the hashing matrix is always semi-positive definite. And there's a famous inequality that applies to convex functions called Jensen's inequality. It's actually the cornerstone for the machine for a branch of machine learning called probabilistic learning. It's called Jensen's inequality. So what is Jensen's inequality? Jensen's inequality says that if x is random variable and f is convex function, then f of ex, that is f of expectation of x, is less than or equal to expectation of fx. That's very interesting, right? And again, because x is a random variable, then a function of x, say gx, is also a random variable. So you can apply Jensen's inequality over gx. You can get a more complicated inequality. So this is often used in deriving some variation lower bound in probabilistic learning. But just keep in mind, there is such conclusion. And then matrix derivative. And if you are familiar with linear algebra, it won't be hard for you to calculate matrix derivative. Why would we care about matrix derivatives? Because all the machine learning algorithm, when we try to implement, we need to first write down the objective function. Sometimes it's referred to loss function or likelihood, whatever. And then you need to maximize this likelihood function or minimize the loss function. How can you do the maximization or minimization? You need to optimize it. You need to call some optimization algorithm. And the optimization algorithm needs you to give its gradient. And the gradient is usually for a set of random variables, or a set of variables. That's why we need to treat everything in terms of vectors and matrices. Then we calculate the gradient, or we represent the gradient in terms of matrices. So I don't suggest you to derive the matrix derivatives by yourself. It's just like templates. Just follow the templates. You are able to do nearly all matrix derivative operations. So here is the basic rules doing matrix derivatives. For example, for a constant matrix, its derivative is 0, and the the derivative of x plus 1 is equal to derivative of x plus derivative of y. Just to check out these basic rules. And also there is a great reference book called Matrix Cookbook online, available. And you can follow the link. Also our course webpage contains a link to the book. And whenever you want to derive the derivatives of some complex loss function or objective function, apply those rules. And first on a hard part, check the reference from Matrix Cookbook. You can solve most of the matrix derivative problems. Okay, this is the basic knowledge review part. I hope this review can help you.
Yeah, we have a class starting this year.